So again, good evening everybody. My name is Donny, and today I would like to talk about some of the importers that I wrote. I want to start off by sort of just exploring the field a little bit to give you a bit of context with what we're working with. The app I work on during the day, we started a big redesign, rebuild of everything last year, and so we started talking about how are we going to do this, how are we going to make it better than it was before. And one of the things that came up was the backend developer saying, okay guys, let's do this. Let's sync all the data at once. Instead of making API calls for each little thing and hitting the server like 10 or 20 times in one session, let's hit it as least as we can. Okay. Okay, I guess. That sort of was my initial response. It's going to be hard. But so we did that, and this is where Sydney mentioned. Importing all the data took about 30 seconds. So we started off with an unacceptable result. Like, this is not going to work at all. In this, there were three big problems. One of them was API dependencies, which means basically that we couldn't do all the API calls at once. There were like 8 API calls that needed to be done. One to fetch app settings. Let's get the images there. One for app settings. One to fetch the events, because we were building an app that was showing events for which you could win tickets. So having the events was kind of important to us. Genres, because each event, of course, is either rock, or it's techno, or dance, or EDM, or whatever. So all the possible categories needed to be fetched. Then we also had the user data. And the user data was actually 3 API calls, one for your prices, one for your favorites, for your profile. The homepage, like what events do we show on the homepage? So all of these API calls needed to be done, and we couldn't do them all at once. The main problem was because we were storing them into CoreData. I'll get to why that was a problem in a sec, but the order of things was a bit like this. First, we needed to do app settings. Most important thing. If the app settings say that you cannot use the app, we show an alert, of course, and we cancel the rest. The second one, all the possible genres, because the events need to know if it gets an ID for rock, it needs to know that ID 1 equals rock music. Then user data and homepage can be done at the same time. So you can imagine that there's a bit of a maintenance problem here. Like, how do we make sure that everything happens in order? How do we make sure that everything happens as we intend? Problem 2, duplication. This is kind of what other objects an event needs. It needs a location, a venue. I mean, it takes place either in the Melkweg, it takes place in the sugar factory or whatever. But each time an event is in the Melkweg, it contains the full location object. So the same location object could be in there like 20 times or even more. Same for countries, categories, artists, text, multiple translations. So a lot of this data is duplicated in the API response, making it very wasteful to parse each location every time. Again, I'll go deeper into this in a second. Third problem, storage. Because of course, especially with the 30 seconds going on, making it faster, the user needs to be unaware of this whole sync process. We need to sync this in the background, the user needs to use the app, and at some point the data is refreshed. Minimal interruptance of the user session. So, the agenda, what I want to talk to you about. The first chapter, chaining operations, which is these API calls. Chapter 2 of this whole story, optimizing the data. So how do we make sure that we are not too wasteful in importing everything? And the third one, properly storing this in CoreData without too much problems. Chapter 1, chaining operations. Who here has seen this talk from WWDC 2015? Probably, yeah. I guess that's for most of us. If you haven't seen this yet, or if your answer was probably, go watch it. It's really good, it's really interesting, and these NS operations, which are now operations without the NS prefix, really interesting, really cool stuff. So, in the beginning I showed you this image with the 4 steps, basically, that we needed to perform. In an operation, it could look a little bit like this. We have a synchronization operation, which has its own operation to fetch app settings. The next one was generous, which has app settings as a dependency. That's just coded in the software. It says, before doing this, it depends on app settings. Events has its own dependency. The homepage, again, it has dependency on events. Then the user data, it's kind of a different animal, because that is very similar to this sync operation, because it has 3 of its own little operations. And this whole block of operations, sync operations, depends on the events being imported. And finally, a little completion operation to perform some stuff that needs to be done after everything is imported, which in turn depends on the homepage. So it still probably isn't too clear, like, okay, you just said the same thing again, stuff has dependencies, I know. It looks a bit like this if you kind of flatten it. Like we have a bunch of operations in the sync operation queue. Like I mentioned, this user data has its own queue. Now, all of these are in the same queue. The order in which you add them doesn't matter. In this case, I added the completion operation first. But because that has its own dependencies, this one is not ready until the dependencies are resolved. So each operation in the queue will be marked ready once it's ready to go, once all its requirements are met. So the first one that the operation queue picks to perform is app settings. It's the only one with 0 dependencies, the only one that's ready by default. So that's done. Then genres become ready, because that was the only one depending on app settings. Now events become ready, so these are all going one by one at this point, and it's loaded. Then something more interesting happens, because an operation queue can do more than one task at once. And as we saw in the little dependency graph that I showed earlier, homepage and user data can both run at the same time. Why not? They're both ready right now. And not only user data is ready, but these operations in the user data queue are also ready to go, because, well, user data is ready, so it can start taking stuff off its queue. So now we have, 5 operations running at the same time. So this is why I like operations queues so much. Because this all just starts executing. Like they all finish one by one or at the same time. It doesn't really matter. And in the end, only the completion is there. And that finishes too, and the sync is complete. So these dependencies. How does an object know that it has a dependency? Do I hard code it in the whole operation? Do I do it on a per operation basis? Well, that last one is the answer. Each operation has a generate dependencies method. It's a custom method that I implemented on a custom subclass of operation, as Apple also shows in this NS operation talk. So if you're going to want to recap this when you're home, do it, because it's really nice. And as I said before, the genre fetch operation depends on the app settings, so that returns this as its generate dependencies value. To make this work, you also need to subclass the operation queue. So whenever you add an operation, you do some details that are not very relevant to what I'm trying to tell you guys here. At some point, it just calls this operation generate dependencies. And then it sort of recursively calls add operation on the operation queue until all operations are added. Once they're all added, we can start to process them and start to perform everything. Then we had this special operation, the fetch user data one, the one with several sub-operations. It uses an internal operation queue, so just its own little instance that it can resume or pause whenever it pleases. And all the operations that you give to the initializer of such an operation are just simply added to the queue, which works similar to adding operations to other queues. And whenever one of these operations finishes, because this operation queue inside of your custom operation queue, at some point it needs to finish. It needs to tell its sort of the other objects or the queue that it's on, like, hey, I'm finished. So it adds a finishing operation at some point in the initializer that I kind of removed for convenience. And once the finishing operation completes, it finishes itself, saying, okay, I'm an operation and I'm done. So I'm finished, everything is completed. And at this point the operation is fulfilled, the dependency is fulfilled, and the next operation can start. So one last time coming back to this one, like I just showed, depends on these two, this one depends on the events, etc. And here you have the 3 operations that are added to the internal queue of the user data. And once it's done, the dependency is fulfilled, completion can start, given that the home page was fetched. So these operations and these operation queues, they solve my first problem. I was able to sort of maintainably set up my dependencies, simplified by the use of operations. The nice thing is that they can either execute in parallel or serially. So if I, let's say, add more stuff that needs to be done before the entire sync is complete, I can just add it as a dependency of the completion operation, and that's all I need to do. It will automatically start, it will automatically be enqueued, and I don't need to touch multiple files or do some nasty stuff with moving a lot of lines of code. And as you saw with this user fetching operation, an operation can contain its own private queue, which makes complex nesting a lot easier. Like fetching a user, of course you want to know what prices they want, of course you want to know what their favorite events are, of course you want to fetch all this. So you can bundle it into the internal operation queue to sort of hide this complexity. All you want to do in your other code is say, hey, fetch the user. And whatever happens under the hood can be hidden very nicely in operations. So, chapter 2, optimizing the data. This is the one where we're actually winning a lot of time in terms of going from about 30 seconds of importing to less than a second, less than half a second even. Like I said before, a lot of this data is duplicated, which has everything to do with the same object being in the JSON file again and again and again and again. The first time I kind of ignored this fact. I was like, you know what, parsing JSON, looping over a bunch of things, it's fast enough, right? I mean, come on, how slow can it be? So I would just loop over the events in the JSON response. I would just find the event in the database or create a new event if it wasn't there yet. Find the location in the database or create a new one, etc., etc., etc. So I was hitting the database again and again and updating the same object over and over again. Kind of thinking like, hey, come on. It's just looping over maybe 1,000 events or something. Shouldn't be that big a deal. So you might be saying, what about this duplicated data? I ignored it. Big mistake. So I thought of this. It's kind of what I was doing, right? Doing the same thing over and over again. And maybe I was thinking that the last event in the response would be slightly different than the first one, which was simply not true. Of course it wasn't true. So let's try again. Implementation version 2. Again, I have to loop over the events. That's one step that could not be skipped. But then instead of accessing each object immediately, I just started storing IDs. So I was like, okay, so I just found a location with ID 1. Let's add it to a set. I just found an artist with ID 8. Add it to a set. Once I had all of them, I would just go to the database. Okay, give me all the locations with IDs that are in this set. And then I update them. So each location or genre or artist is only fetched and updated once. And not only is it done only once, there's only one query to fetch all of them and one query to save all of them. And that was a huge improvement for the speed of this implementation. Then, of course, I had to loop over the event objects again, which was a slight lose in my opinion, but kind of had to. And then just say, like, okay, so I just fetched this location with this ID, attach it to this event that I just created or fetched. Which is, as you can imagine, a lot less wasteful because you're only touching each relationship once instead of many, many times. And then, of course, in the end, you persist the database and you're done. So what do I mean by collecting all these unique events and relations? The code kind of looks like this. Of course, it's a lot longer than this, but the main idea is that you loop over all the events, you store the event ID, so you're gonna see if you can fetch it or you have to create it later, and then just access, like, okay, so the location. Can I get it? And add the ID to location IDs. Do the same thing for each and every relationship. So you end up with a big list of IDs for each entity. And this was really the takeaway for me. Like, so each object is only fetched and updated once instead of doing it. I think the worst case was maybe 100 times or something, 50 times. Way too many. Okay, so this solved problem 2, and this was basically the biggest win in this whole importing situation. So what was the takeaway for me? Collect IDs for unique objects, because you only need to fetch them once. It's not like the same object with the same ID is going to have different values in the same response. Fetch everything in one go. Less queries is more speed. And make sure that each object is only updated once. Again, doing less is faster, always. And it can be a good idea to just totally pull apart the data that you get from any backend before you process it. Because, well, in my case, I won like a huge speed improvement, but I guess this could be the case in many, many other cases as well. So, on to the last problem, storing it in CoreData. Now, I said this, you know, the user shouldn't really notice that we're doing a sync. It should just happen, and it should be smooth, and the UI should never freeze. So you guys might say, well, if you're familiar with CoreData, easy. Use multiple contexts. One for the UI on the main thread, one in the background for the background thread, done, right? The answer is actually yes, that's the way to go, but if you do this, and you have this, and then considering the stuff that I mentioned earlier, with all these importers, and there's a bunch of stages where you're going to save data, your users are going to say this, because the UI is flashing a bit. Like first you fetch app settings and you save those, then you fetch event, you save those, and the user profile, you save those, and it starts flashing a bit, like maybe 8 or 10 times, depending on how often you save your managed object context. This was what I came up with first, which caused this problem that users mentioned before. Whenever the managed object context saves, I have new data, so I update the UI. Very naive, effective though. Everything was always up to date. But each operation in this dependency graph saved, and then the UI updates, and it wasn't pretty, it wasn't nice. So I figured I can do better. Now, considering this sync helper operation, I made the app settings one dependent on kind of a dud operation. The only thing that operation did was fire a notification that said, hey, we're going to start a sync now. And when that operation was complete, so when the notification was fired, only then would I start actually fetching data. So managed object context did save, that notification fires. I made one central place to catch all of the managed object context notifications, and I just hold on to it. Just store it in a set and keep it around. At some point in this completion operation in the sync helper that you saw before, I fire a notification again. I say, hey, this is the last thing that needed to be done, so everything is finished now. At that point, I would go over all the CoreData notifications that I got and figure out, like, did an event just update? Did the user just update? Did this just update? Did the homepage update? And then just fire a single notification for each entity. Because why fire 5 notifications for events if the result is going to be 5 refreshes of your UI? And it's not like 5 different places listen for slightly different events. So one notification for each entity was sufficient. And that solved my third problem. The UI wasn't flashing anymore. So yes, I did use multiple contexts for reading and for writing to make sure that I could write on the background thread and read on the main thread. But this was a sort of a thing that I was like, hey, this might not be straightforward. Just store all the notifications that you're getting if you're most certainly going to refresh again when everything is finished. And this was also quite sort of something I was like, okay, this could be really clever. Just only fire notifications that you really need to fire. Create a filter between CoreData and your app to make sure that you don't update your UI if it's not necessary at all, like it was in my case where an event updated, and then another event updated, and then the user updated, and the user updated again and again. And you only want to refresh your users once. It doesn't make sense to do it 3 times in a row. So the main takeaways of me and my importers is that operations can make a very complex process very easy to manage. Second of all, it might be nice to pre-process API responses before you import them or before you really try to use them, because they could contain a lot of duplicated data that makes processing really slow, and you could speed it up by collecting unique stuff before trying to do things with it. And lastly, inserting a layer between your app and CoreData can really help sort of cleaning up what CoreData does in the background and help you manage what you want to do in your app. And of course, when I was done, I had actually it was a beer, but I figured wine would be nicer on my slide. So that's it. Are there any questions from you guys?
I have a stupid question. Why do you have so many saves if you say that you create an update object only once?
Why I had so many saves? That's a good question, I guess. So each of these operations that I had, so the app settings are fetched and they're stored in CoreData. At that point, I want to persist the database because the next operation is not guaranteed to finish. Then I fetch all the categories for events, and when those are finished, I want to save them, of course, because etc., etc. So you can see why each operation has at least one save. And the user one, for instance, has 3 operations, which is 3 saves, meaning that potentially you're reloading your user 3 times. Even though the last time is the only one that makes sense because that's when the user is completely imported. So that's why I had so many saves. You want to make sure that each step...
Each operation is a comment on performs one modification of an object and then saves.
At least one, yeah. But in reality, of course, if you, let's say you have this user and you create some relationships with the user, it could be that both an user and an event are dirtied. So in your notification, you get that the user changed and an event changed. Even though you don't want to refresh the event because the event didn't really change, it's just that it has another user that marked it as favorite. That's what you catch. So you say like, okay, so what entities changed? And you just fire one notification for each different entity. I see your brain going like this. You're thinking.
How do you handle like if one of the operations, which are dependent on one of the others, fails? Like, if I'm right, this is all happening in the background.
Yeah.
So you're not asking users to retry something?
No. So what happens currently is I just call finish anyway, because if you cancel an operation, then the dependency isn't fulfilled, so the next one won't succeed. So each operation in reality for me has a check to see whether some data is there that it depends on. So if the dependency was really fulfilled, or did I just pretend it was fulfilled and set an error somewhere else. So it just checks that, and otherwise if there's an error, it sort of just finishes immediately. And then at some point in the end, the completion one does the final check, like, okay, so did we finish successfully, or did we finish with errors? And if it finished with errors, it can notify the user, like, hey, we couldn't fetch all the data, try again later.
The question about chapter 1, you said that the data that comes from the backend sometimes with duplicates and so on. Do you have this kind of access to the backend development? I mean, is it possible to adopt backend development for the actually client?
Theoretically, yes. But yeah, we had many discussions internally about this, but he was pretty adamant on, like, a location is an entity and it should be returned as one. So.
Yeah, because sometimes you know this, you can think from the backend as kind of microservices, entities, and you can just have a raw access to this. And sometimes you can just return from the backend to the view that necessary for the client.
Yeah.
And it would be optimized, and in terms of traffic, in terms of usability, it could be much convenient for the client.
I know, yeah, that's why sort of in the beginning I was like, okay, I guess. There are many other solutions, of course. To be honest, in terms of the learning experience, this was great to do.
Yeah. Sorry, you have one.
Fine. Keep them coming.
Well, this was really interesting, and I'm very curious about the implementation because I haven't really actually seen any frameworks that use this operation for data in one. Have you made by chance open source framework and put it somewhere for others to look?
No. First, you don't need a framework for this at all. No, I haven't open sourced anything about this, but if you watch this NS operation talk by Apple, it will make a lot of sense to use CoreData with it as well, because Apple will themselves even use it for view controllers and managing which view goes where. And you can do pretty complex stuff with it, and kind of at the core is just something that says, hey, I just started doing something, I was done doing something, and something can be anything. But if you want, we can talk after this, have some beer, and talk about this more. I can even show you some code if you want to.
If you also use CloudKeep, how do you synchronize between the two, CoreData and CloudKeep? It's always like...
If I were to add CloudKit, I don't have an answer. No, sorry, I'm trying to come up with something, but I haven't worked with CloudKit a lot. I looked at it really shortly, but so I'm gonna have to owe you that answer someday.
Apple has a huge overview on keeping local cache of CloudKeep, but in practice it's quite complex.
Yeah, I have heard a lot of stories about sort of Apple pretends it's really easy, or other people pretend it's really easy when they try to do it, and it's kind of messy, right? Yeah, I heard about it.
Sorry if I misunderstood. You were talking about collecting all the notifications.
Yes.
And only update the UI once per entity.
Yes.
So what is an entity in that story?
For instance, so basically any database table, even though CoreData doesn't work like that, but you have, for instance, I have an event entity, which is just an NS managed object subclass, and one for location, one for user, etc.
Basically, you update at the end, right? When you finish.
At the end, yes. So once I have collected all the notifications, and then the sync helper fires a notification and says, I'm done. At that point, this one huge hub that collects all the notifications that CoreData and the sync helper produce together. It's like, okay, so we updated maybe 100 events, but we only want to reload the calendar once.
Exactly, but don't you have any conflicts with like multiple inserts and deletes? And
That's why I saved them until the end.
okay.
Why not only save the last one?
Why not only save the last one? Because the first one could be the user, the second one could be an event, the third one could be a location, and then the last one could be an event. So in that case, I would miss the user.
One per time?
Sorry?
One per time?
It keeps a set, actually. So you caught me.
And if you don't have one of those, or one of those failed,
If one of those failed, I will still have a notification for whatever succeeded. And if everything failed, then it will just fire no notifications because there was nothing to update.
I was wondering about what kind of managed object context architecture can you use?
It uses both the iOS 10 NS persistent coordinator thing, and also just regular parent context and child context, like it was before iOS 10. So it uses both. And I create a little abstraction that just creates a new background context whenever I ask for it. So if each time I ask for a background context, it's actually a new one, because that's also how the NS persistent coordinator works. So I figured just mimic that in my pre-iOS 10 code.
Any of this in your repo?
Little parts of it.
When is it out?
I heard they were going to send it to the press next week. So we'll see.
What's the subject?
It's iOS 11 is the subject. Yeah. So a little bit of CoreML, a little bit of Vision, a little bit of everything. Any more questions? All right.